Okay, so let's do an example. So let's do like a kind of a lemma, an example application. Okay, so let R be a ring and M be an R module. Okay, if I is an ideal in R, then we have the following. So this is kind of a cool thing that you can do. So M mod IM. Okay, so the kind of the reduction of M mod the ideal. This is isomorphic to M tensor R mod I over R. Okay, so let me give you the proof of this. Okay. First of all, this is pretty cool because it says that like to do something reduction mod I, all you really have to do is just tensor. Okay. In particular, when M is a ring, this is kind of useful too. But let's look at this. So we have an exact sequence. Of R modules. So here's the exact sequence. 0 goes to I, goes to R mod I, goes to 0. Okay, so let's tensor this with, we tensor this sequence. With M. Okay, and so we get 0 goes to I tensor RM, goes to R tensor RM, goes to R mod I tensor RM, goes to 0. Okay. Oh, sorry, we don't get this side. So we don't get this side. So this is by right. So this is by, we get this thing here by right exactness. So let me just say, so this thing here, this part is by right exactness. And that's because right adjoints preserve co-limits, right? And this is really a co-kernel here, this thing here. Okay, so now let's kind of just do some things here. So this is the cancellation property, or maybe let me do it in other colors. Okay, so this thing here, so whenever you have this is cancellation. So this is isomorphic to M. And then this thing, the image of this. Okay, so now we have that. So from this sequence. Okay, so from this sequence. We have that the image of this is the kernel of this map. Okay, and that this map is surjective. Okay, so the image of so we have this thing R mod I tensor over R of M is isomorphic to M modulo the image of IRM into M. Okay, and what's the image here? This is just this thing here is just M mod IM. So the map here, so the map, so yeah, so let me just say what this purple map is. So this map here, it takes R1 tensor RM M1 plus R2 tensor RM2. This thing maps to R1 M1 plus R2 M2. Okay, so that's the isomorphism there. So in particular, this thing goes to I, so we'll have IM, and so this thing is just IM. And so then we have here, this is what we have, this is what we proved. So the image of this thing is just IM. All right, that's cool. I like that. Okay. All right. So let's do another example. So let's do a lemma, I guess. So there's a couple ways we could do this. So I have that free modules are flat. Let me do a lemma here.